So looking at the infographic that they have for how this particular company prices their data storage, we want to use this information to fill in the table. What is X talking about here? What does X mean? It says intervals of X. What are we talking about? What is it that would be between 0 and 0.5? Between 0.5 and 1? Between 1 and 2 or more than 2? What are they talking about doing? What's being described in this infographic? Guys, put the phones away, please. What is being described in this infographic right here? What is it giving me information about? Data storage. So this is telling me different amounts of data that they are wanting to store in terms of terabytes here. So terabytes of data. So what would D of X be telling me about? If X is telling me about data storage, what's the other information that you would need to make a decision here? Like, I need to store this much data. What's the other piece of information being given to us in this infographic? The price. D of X is describing the price for different storage amounts. So how much do you have to pay for between 0 and 0.5 terabytes? How much do you have to pay for between 0 and 0.5 terabytes? $5. So this is right here. 0 to 0.5. Why doesn't this have an or equal to on it right here? Well, this isn't telling me $0. Remember, X is telling me about storage.
Oh, you can't buy zero storage.
Yeah, like if I need 0 terabytes of storage, I don't need to pay for it, right? It's only if I actually need some storage, something bigger than 0, then I would have to pay $5 a month if I only need a little bit. How much do you have to pay if you need more than half a terabyte, all the way up to 1 terabyte? How much would that cost you? $10. In between 0.5 and 1. What about if you need between 1 and 2 terabytes? More than 1, all the way up to 2. 15. So more than 1, all the way up to 2. What about if we need more than 2 terabytes of storage? 25. More than 2 terabytes.
So sorry to interrupt. I'm gonna have to take David for testing.
Okay.
Is he here today?
Yes, he is. David?
Thank you. Bring all his things.
David, bring all your things with you. Yep. Okay. So we've filled in this table. How much would you need to pay if you needed 1.25 terabytes of data storage? How much would you have to pay? 15. What about if you just need a little bit? You just need like 0.3 terabytes of storage. How much are you paying? $5. Is there any amount of storage that would have you sending this company $7.50? No. If you only need a little bit, it doesn't matter if it's 0.1 or 0.01, you have to pay $5. And you pay $5 all the way up until when? Yeah, up until half a terabyte, up until 0.5. You pay this flat price of $5. If you need more than half a terabyte, even if you just need 0.51, what does it jump up to now? Now it jumps up to $10. The very second you go over 0.5 terabytes of storage, they jump you up to the next pricing plan. And now you owe them $10. I've got a couple graphs here. I want to pick out which of these graphs is showing me $5 a month for half a terabyte or less, $10 a month for between half and 1, $15 a month for between 1 and 2, and if I want more than 2, I pay $25. Which of these graphs is showing me that? Or you could even start off by telling me, well, I know it's not this one. Tell me any of them that you can throw out, or if you think you know the right answer, tell me that too. We can throw B out. Tell me why. You're absolutely correct. Tell me why. Yeah, it is discrete. And this data is not discrete because this is saying you will use a half a terabyte of data. No less, no more. You have to use it all. Is that realistic? No, you might buy that much storage, but you don't necessarily have to use it all. Your usage can be anywhere smaller than that, and it's okay. So we can definitely throw out graph B. There's another one that I see I can throw out. It looks very similar to the others, but I'm looking at this piece right here. What does this part of the pricing plan tell me? I have to pay $25 when? If I want more than 2 terabytes.
So take out C.
Take out C. Why are we throwing out C? Yeah. It's saying that the maximum amount of storage you can get with them is 2.5. That is not what this is telling me right here. This says it goes anything bigger than 2. So if I need 10 terabytes of storage, I should be able to get it for $25 per month, according to what is written here. This graph right here does not continue going on to larger storage amounts. It stops me. So that's why I'm going to throw that one out. So now we've got it narrowed down to A and D. What's the only difference you see between those two graphs? It's the only difference that there is to notice between those two graphs. They look almost identical. One tiny difference. Open and close circles. I'm going to look at the left-hand side circles and compare those. On graph A, they're filled in on the left and open on the right. And on graph D, they're open on the left and filled in on the right. If something is filled in, that means it's telling me the price that I would definitely have to pay for that amount. If it's open, like right here where it's open, that jumps me up to the next one because it's filled in there. When I look at this one right here, my eyes are keyed on this piece right here. See that filled in dot at $5? How much data are they saying you would get for $5 right there? 0. If you're not getting any data, are you going to pay them any money? This one over here has an open dot. It says I only have to pay for things that are bigger than 0. If I need 0.1 terabytes of storage, do I have to pay for it? Yes. What about if I need 0.01 terabytes of storage? Do I have to pay for it? If I need anything more than 0, I have to pay for it. That's what this graph says right here. That one says I have to pay for it even if I'm not using any. This one says I only pay for it if it's bigger than 0. So this is my correct choice right here. Option D. What would my domain be? Domain is talking about storage, because that's my X. Amount of storage. What kinds of amounts of storage make sense? What are possible amounts that people might choose to purchase? Could somebody purchase 5 terabytes?
Yeah.
4?
Yeah.
2.5? 37.
Yeah. Well, yeah.
They could, right? That's a lot of storage, but they could. Maybe it's a large corporation and they have a lot of data to store. Are you going to purchase 0 terabytes of storage? Are you going to purchase -4 terabytes of storage? So there is a boundary here somewhere, right? It's not all real numbers because you just told me that some of those numbers don't make sense. What's the smallest value that we're like, nothing smaller than this? Yeah, nothing smaller than 0. 0.1 in a realistic sense, yes. Maybe there's somebody that needs like 0.01. So it could get smaller, but it's never going to go smaller than 0, right? They might only need an itty bitty bit of storage, but it's not going to get smaller than 0. So for my domain, I would say my x's all have to be bigger than 0. There is no amount of storage that makes sense that is smaller than 0, but everything bigger than 0 makes sense. If x is telling me about the amount of storage, and that's my domain, what is range explaining to me here? What'd you say? The price. What are the different prices that we would pay for storage, or that anybody would pay for storage? It's $5, 10, 15, and 25. Would anybody have a single storage plan and pay this company $20 a month? If they have a single storage plan, would they pay $20 a month for their storage? No. It's either going to be 15 or it's going to be 25. You fit in one of these buckets. They don't have a plan for $20. So this is not y is greater than or y is less than. I'm going to name these different prices. Whenever I see these steps like this, my y values aren't increasing, they're not decreasing, they're flat. And I can count how many different y values we have. I'm going to list them out in that case. What did you say that list was? What are the different values we could have for our prices? 5, 10, 15, and 25. All right. There is one last type of piecewise function that we need to talk about. We talked about just piecewise in general on the first day, on Wednesday. This is where we have different rules for different parts of my graph, and we cut them apart with these fences, and we have to know where each of them lives. Yesterday we talked about this special type of piecewise function. What's this one called again? This is a step function. The last kind that we're going to talk about today is called an absolute value function. Page 51 in your books. Absolute value function. Does anybody remember from Wednesday on our bell work, we defined what absolute value means. Does anybody remember what absolute value is? What'd you say? It is sometimes going to be a whole number. That's it. I think you're thinking integer. Integers are whole numbers. You're correct there. Absolute value. Huh? Exact value described as a distance away from 0. It's always going to be what type of number, because we're talking about distance. Positive. Absolute value tells me the distance away from 0. This right here is how we write absolute value. Do you guys see the x in between like those two bars in the function rule here? Do you guys see the bars on either side of x? When you see that, that is how you know we're talking about absolute value. Absolute value bars. When I'm writing this on my own paper so that I don't get them confused with ones, I make them really big. Like on lined paper, I make them take up the whole line so that I don't accidentally misread this. This isn't 1x1. This is absolute value of this piece on the inside. Does that make sense? Be careful when you write it down yourself. These are not ones. The parent function for an absolute value looks like this guy right here. And this is my function rule for the parent. A parent function is going to be the most basic function of that family group. So this is absolute value of just x. We're not adding or subtracting anything. We're not multiplying anything by it. All the other absolute values in this entire family are going to have this same shape to it. They're going to have this V shape. This point down at the bottom, where the two lines come together, this is called my vertex. Does this graph have any intercepts? Does it have an x-intercept? Does it have a y-intercept? Does it touch the x or y axis at all? Yeah, where? At the bottom is 0, 0. So it definitely has at least one x-intercept, at least one y-intercept with the way this is. If I were to take this graph right here and I were to shift it up on the screen, still with the same grid behind it, I just took the blue part and shifted it up on my graph, would it still touch the y-axis? Yes. Would it still touch the x-axis? What about if I took this graph and instead of shifting it up, I shifted it down? Would it still touch the y-axis? Would it touch the x-axis? If I shifted it down, would it still only touch the x-axis in one spot? Then it would touch in how many places? 2. So when I'm thinking about my intercepts, there will always be one y-intercept. It's always going to touch the y-axis somewhere. For my x-intercepts, if it's been shifted up, it's going to have 0. In this picture, we have how many x-intercepts? 1. Or if I shifted it down, it would have how many? 2. So 0, 1, or 2 x-intercepts. We'll always have a y-intercept, and we will always have only one y-intercept. Domain and range. What would my domain for this be? Not 0. Domain tells me all the things I'm allowed to use for x. All real numbers. When I see it going off to the left with an arrow, I know it can get all the negative numbers this way. When I see it going off to the right with an arrow, I know that means it can get all the positive numbers. If I've got all the negatives and all the positives, I have all the numbers that there are. So my domain is all real numbers. What about the range? What am I looking at now? Am I still looking left and right for range? Now I'm looking which way? Up and down. positive numbers. Positive numbers are any numbers that are bigger than what? 0. All of my y's are greater than or equal to, because we've got that little vertex that touches, greater than or equal to 0. You could choose to write this using interval notation. We would say it starts at 0 and it goes on to infinity. Either one of those would be a correct way of describing the range to me mathematically. We're talking about this in piecewise functions because this is an example of a piecewise function. If I were to cut this graph right in half, right here, through the vertex, pretend I can't see this side at all. If this was all I were to show you, you would tell me that that is the graph of what? What does that look like? A straight, yeah, looks like a straight line. That looks like a linear function, right? What about if the only thing I were to show you about this graph was the other side of it? What would you say that is? Looks like another linear function, but it looks like a different linear function than the one on the other, because this should go down then, right? But when I cover up the other side, when I put them together, is that whole thing a linear function? No. It's two linear functions where one lives on one half of the graph and another linear function lives on the other half of the graph. So this is an example of a piecewise function where we've taken two different lines and stitched them together right here through the vertex. Page 51. We're going to graph an absolute value. We're on example number 5. Here's the absolute value that we're going to graph. What does absolute value do to things again? This part will be a positive because this is the part that has the bars around it. And then what am I going to do to that number after I find how far away that piece is from 0? What do we have on the end? Plus 3. If I add 3 to something, is that going to make it bigger or smaller? Bigger. If I add 3 to a number, and that's describing my output, would that shift my graph up or down? It's going to shift my graph up. That plus 3 on the end there is going to shift this whole graph up. I want to know what this graph looks like. So we're going to fill in this table here. I have my rule. Do you guys see these absolute values? Ooh, that's huge. Do you see these absolute value bars on either side of this? That's going to take whatever's inside there and it's going to turn it into a positive number for me. And then after I do that, I'm going to add 3 to the answer. What's the first number that they would like me to substitute in for x? -4. There should be a bunch of calculators out. I have a lot more calculators, but we are going to substitute in. Do you guys remember where the fraction button is on the calculators? It's the button that says n over d. It is close to that green second button. All right, I'll bring you another one. There you are. We want to fill in this table with our values. All right, somebody else. There we go. Does everybody that needs a calculator have one now, or does anybody else still need one? You with me, Shadrach? Okay. I want to do 3 over 4 using that fraction button. If anybody doesn't remember where the fraction button is, please raise your hand. I'm happy to come and show you. We're going to... Yes?
He said 0.
0. Because I end up with what value from doing this? What is 3/4 times negative 4? Negative 3. But what are those absolute value bars doing to that negative 3? They're going to make it positive. That's what absolute value does. That's what those bars around it are doing. I'm going to evaluate what's on the inside. We got a negative 3 from doing that. But then I have to take that number and I have to make it positive. So I'm going to have a positive 3 plus 3. What is 3 plus 3? 6. So I need my ordered pair that I'm going to plot here. What was the x that we substituted in? Negative 4. And what was the output, the y that we got back? 6. I need to plot that point. Let's see. 1, 2, 3, 4, 5, 6 is going to be up here, right? I would need to extend my graph out if I'm going to go up to 6. All right, so negative 4, 1, 2, 3, 4, and 6 right up here. What's the next value they want me to substitute in for x? Negative 2. What is 3/4 times negative 2? What is 3/4 times negative 2? Negative 1.5. What's the absolute value going to do to that number, though? It's going to make it a positive, so I have 1.5, and then I have to remember to add the 3 to that. What's 1.5 plus 3? 4.5. So where does my next ordered pair go? Where's my point? What's the x part of this ordered pair? Negative 2. And the y part of my ordered pair? 4.5. So now I need to go and plot that point. Negative 2 and 4.5. So sitting about right here. What are we putting in for x next? 0. That makes this a whole lot easier, doesn't it? What's anything times 0? 0. How far away from 0 is 0? 0. So I have 0 plus 3, which gives me what? 3. So where am I going to plot this point now? 0, 3. The x was 0, the y was 3. So right up here. What am I putting in next for x? 2. What is 3/4 times 2? 1.5. How far away from 0 is 1.5? It is 1.5 units away. But then I need to add 3 to that, coming from right here. And I get what? 4.5. So where does this ordered pair go? Two and 4.5. Head up for me, dear. 2 and 4.5. Last point that we need to plot. What are we putting in for x? We're putting 4 in for x. What is 3/4 times 4?
6. 3/4.
Huh?
3/4 times 4 is
3. What is the absolute value of 3? How far away is 3 from 0? How many hops? It's 3 hops away. So I have 3 plus 3. You were just a little bit ahead of me, Jaden. When I combine those together, I get an output or a y value of 6. Did anybody notice a pattern happening? What happened when we got on the other side of the vertex? My outputs started to repeat themselves, didn't they? Yes, sir.
Would this be considered a reflection?
We would say that it is symmetric and it has line symmetry. So yes, it has reflection symmetry or line symmetry on either side of the x value where the vertex is. That is absolutely correct. Yep. Sketch in my graph here. And now I want to try to describe the domain and the range for this thing. What would the domain be for this? What kinds of things could we choose to substitute in for x? What'd you say? All real numbers, yes. All real numbers.
Can't just put that R with that.
This guy? Yes, you can absolutely write that instead of all real numbers. Usually up here on the screen, I'm going to write it all out. But on your own notes, if you want to use that R with the double line, go for it. Absolutely. What about my range? Am I still scanning left to the right? For range, I want to scan which way? Up and down. What do you notice about this graph when you look at it from up and down? Does it have a lowest value? Does it have a highest value? What is the lowest it ever goes? 3. All the other y values are bigger or smaller than that? Bigger. So my y values are greater than or equal to 3. Or you can write this using interval notation. You could say 3 is my smallest, my minimum. It has no biggest. It goes to infinity. All right. I want to do one more graph with absolute value. We're going to be on the next page. We just graphed an absolute value using a table. That's one of our methods for graphing linear functions. We're going to use graphing with a table a lot this whole semester. Since it is a piecewise, I could describe this as a piecewise function where I have f of x equals, and my curly brackets. When I think about an absolute value, I'm going to go back to that last graph. This would be one function rule, one piece, and it's been stitched together with this one over here. So how many pieces does an absolute value have? 2. I would need one piece for each side, and I can come up with that rule. Put it away for me, sir. There are 2 cases where we need to consider this. Case 1 is if the part inside the absolute value right here is positive. If I have a positive number inside the absolute value, like 7, how far away from 0 is 7? How many hops would it take to go from 0 to 7? 7 hops. So absolute value of 7 is 7. What about the absolute value of something like 42? 42. Is the absolute value here changing this number at all? So if what's inside here is positive, nothing changes. I can rewrite this without the absolute value if it's positive. So that would give me this for one of my rules. What can I do with this to clean it up? multiply. I'm going to use the distributive property. I'm going to distribute -2 to each of these pieces. So I get -2x minus 2. All right, so that's one case, if what's inside the absolute value is positive. What's the other possibility? If it's not a positive number, it would be a negative number. So case 2 is if this is negative. If I had -14 inside an absolute value, how far away from 0 is -14? 14 units away from 0. I want to think of another mathematical operation that I could use right here. What could I do to -14 that would give me a positive 14? What operation could I do to this that's not absolute value? How can I take something that's negative and make it positive without changing its value? Could I add something to it to make that happen? Would I subtract something from it? Could I multiply or divide? Taylor's nodding. I want to think about something that I could do no matter what the number is inside. Same operation each time, no matter what. That would just take my number and make it positive. Could I add the same thing to -99, -2, and -14 and get these outputs? No. Could I multiply these by the same number? -14 times something, -2 times something, -99 times something, and get those values? What can I times -14 by to get a positive 14? -14 times 1, or sorry, times -1 would give me a positive 14. Could I do that same operation to a -2? -2 times -1, would that work? That would give me a positive 2. -99 times -1 would take it and change it to a positive. So if I already know that what's inside this absolute value is negative, I can make it positive by timesing it by -1. So that's what we're going to do. We're going to multiply by -1 if I know it's already a negative, because that'll turn it into a positive number. So I'm going to distribute a negative to everything here. So I have -x minus 1. And I still have that -2 out in front. Can I simplify this even more than that? Can I do anything more to this? Yep, I can distribute that -2 to each piece. What's a negative times a negative give me? A positive. So f of x equals positive 2x plus 2. Here's my 2 rules for my 2 cases, right here and right here. I want to look at how we're going to graph those. This is similar to what we practiced on Wednesday and what we went over at the beginning of class yesterday. You with me, Jaden? Not so much. Head up, dear. Stick with me. Okay, head up. Thank you. Here's what my piecewise function looks like. Here's one rule. Here's another rule. I need to know where each of these rules is living. Your book has one way of describing where that fence should be, and it'll get you the right answer, but they went about it the long way. Do you guys want to see a faster way to get to the same answer? If we want to figure out where that fence is, I'm looking at this part right here, inside the absolute value. Michael, what's written inside the absolute value there? What is written inside the absolute value? Ibrahim, you're not off the hook either. Ooh. I'm looking right up here. In that original function rule, what is inside the absolute value? I want this. Yep. X plus 1. So I take x plus 1, this is the part inside the absolute value, I'm going to set it equal to 0. Every time I do this, I set it equal to 0. Yes, you may. All right, Ibrahim, here's the part where you're going to answer me. We've set it equal to 0. I want to know what x is equal to, because that's going to tell me where my fence is. Yes, sir. Yes, you may.
He said one more time.
Yep.
Oh, my bad. I dropped your picture.
You're fine. I want to get the x all by itself here. I have an equation, so I can solve it for x. I want x all alone, because that tells me where I'm going to put my fence.
Right.
How do I get x alone?
Subtract 1 from both sides.
Subtract 1 from both sides. And when I do that, I get that x is equal to what? It is negative 1. 0 minus 1 is negative 1. This right here is what I put in both of these spots. This is my fence. This is where my fence goes. All right, so now I know how to find where my fence is. I have the rules for both sides, for both cases. If what's inside the absolute value is positive, I have a rule for that. If what's inside the absolute value is negative, I have another rule for that. Now we're going to graph this thing. This right here, these are my addresses. Tells me the location. This number right here tells me where my fence goes. I'm only going to have one fence because it's just separating out these two guys. What kind of line will I draw in for the fence? Vertical or horizontal? What does the fence look like? Like this? We're always dividing up our yards this way. I'm going to put it at negative 1. That's over here. Which rule lives on which side of the fence? Where does this one live? On the left. How do you know? Less than. So that tells me left. He lives on the left side. So I'm going to write 2x plus 2 over here so that I know he lives over there. And that means this guy lives where? On the right side. So I'm going to write that up above. Negative 2x minus 2. Which rule owns the fence? Which one would get the solid, the filled in dot? This one right here, right? Because it has that or equal to. So he gets the filled in dot where he hits the fence. This one does not. Which side is the y-axis on? The left or the right of my fence? Right side of my fence. Let's go graph that one first then. I'm going to ignore this side for right now. I'm going to graph just the right side because I can use my slope and my y-intercept to graph this here. Where is the y-intercept for this side? What is my y-intercept over here? -2, coming from this one right here. Here's my y-intercept. So I'm going to go and plot that point at -2 on the y-axis, not on the fence. What's the slope? Also -2. How do I graph a slope of -2? We go down 2 and we run right 1. So from this dot right here, I'm going to go down 2 and right 1. We said he gets a solid dot on the fence. Where's it going to hit the fence at? 0, because I can reverse this. If I go down 2 and right 1, how do I back that train up?
Up 1, right 2.
Yes, up 2
Oh, up 2.
and left 1. I do everything backwards. Everything 100% in reverse. So right here. And I'm going to sketch that line in now. So this side of the fence looks like this. Are we done? I have to do the other side. I got one side of it. We got to go get the other side. So I'm going to switch which side I'm looking at. I'm not paying attention to this side anymore. I'm only looking over there. I have a rule that has a slope and a y-intercept. Do I see the y-axis in that yard? So using slope and y-intercept isn't going to help me because I can't put a dot on the y-axis. I'm not allowed to touch it. That's in the other guy's yard. What about if I made a table to get a couple points here? Would that help me figure out where I could put these points? All right. Let's do an XY table for this. Do I want to know where it's going to touch the fence at? Yes, I do. That fence is where on the x-axis? We said it was where? Where's my fence? -1.
Yeah, that's
And then I have to pick out only other x's that I can see over here in this yard. Can I do like 1, 2, 3, 4? What are some things I could use? -2, -3, -4. How do I figure out the y parts then? What do I do with the -1, -2, -3, -4? So I'm going to substitute it into what? F. Which rule? Which rule are we looking at right now?
the second one.
Yeah. So to find this, I'm going to do 2x plus 2. What are we putting in for x the first time? -1 plus 2. What's 2 times -1? -2. What's -2 plus 2? 0. So -1, 0. It gets an open circle, but it lands right on top of my other one. Next thing I substitute in for x. What'd you tell me? -2. What's -2 times 2?
-4.
What's -4 plus 2? -2. Stick with me. So I have a point at -2, -2 right here. What's the next thing we said we're going to substitute in? -3. What's 2 times -3?
-6.
Plus 2? -4. So I need an ordered pair at -3, -4 right here. Am I going to be able to go lower on this? I'm going to run off the screen. What would my output be if I substitute in -4? Since we put it in our table, let's go ahead and calculate it. What do you notice happening to my outputs each time? They're changing by the same amount, right? Got smaller by 2, got smaller by 2. So what's this number going to be? -6. That's not on my graph. My graph ended at -5. And I have enough dots to draw it in, so I'm not going to keep going. So I get this guy in here. There's my absolute value graph. We could have done it just with a table. I graphed it as a piecewise so that we could get a little bit more practice with graphing a piecewise function. If you want to do it just with a table, that is perfectly okay, as long as you put the vertex in the middle of your table when you do that. You need the x part of the vertex in the middle of your table if you're going to do it with a table, because you need to see what both sides look like. So you need some points on either side. What would my domain for this be? All real numbers. All real numbers. What about my range? Is the range all real numbers? Michael says yes.
I say no, just because he said yes.
Ibrahim says no, just to be contentious.
All real numbers is the.
It's not all real numbers.
It is not all real numbers.
Oh.
Why not?
Because the graph doesn't go on forever.
Graph does not go up forever. It has a highest point. It has a maximum, right? Where is my maximum at? At 0. All the rest of the graph is above or below that? Below that. So my range is y is less than or equal to 0. Or I can write it in interval notation. Since it has no minimum, it goes on forever. Negative infinity would be the smallest. All the way up until 0, that is my maximum. And I have a point there. It is a filled in dot here. And so it gets a square bracket. All right. That's all I got. We are now in our study time. Homework is due on Monday. It is due Monday night, so I want you guys to work on that. You've got all weekend to work on it. And you still have time to ask me questions on Monday before it's technically due.